scientific shorthand, and making zeros cool again. All that today when we pause for a moment of science. In science, and especially in chemistry, we know it's important that we have to collect data. All right, if we don't collect data, we can't prove anything. We have to have data on whatever experiment it is that we're doing. And to do that, we sometimes use something called scientific shorthand or scientific notation. I call it scientific shorthand because that's all it is, taking a big number and squishing it down to where it's really small, and then it can be used all the time. It means the same thing everywhere. Okay, you may have talked about the metric system before, and basically what the metric system is a version of that scientific shorthand. Okay, it takes big numbers, makes them really small. All right, and we can do a couple of examples with that. Behind me, you'll see 3 with a bunch of zeros, meters per second. Okay, those of you who are familiar with Albert Einstein may know that his constant C equals mc squared, right? C is 3 times 10 to the 8th meters per second. Okay, times 10 to the 8th power is scientific notation, scientific shorthand, okay? And what it tells you is that this 3.0 times 10 to the 8th meters per second, all right? This decimal gets moved 8 times. Whatever the power is how many times you move the decimal to the right, okay? That's if the exponent is positive. If the exponent is negative, then you're going to have to move the decimal to the left, all right? So make sure you remember, positive exponents move to the right, and then negative exponents move to the left. All right? So this right here is a really big number. And if you kind of look at how many zeros this has, it's huge, right? All right, and this is something that we're going to be using a lot in chemistry, and we're going to have to use that shorthand. It's called Avogadro's number. Avogadro's number is 6.02 times 10 to the 23rd power. That means you move the decimal to the right 23 times, all right? Now, I don't think and I don't expect you to take and write every one of these zeros out every time you work on a paper. No, that's just crazy, all right? I wouldn't do that to you. I'm not that mean. Kind of mean, but I'm not that mean. But, okay, what we do instead is we take this scientific shorthand. We go 6.02 times 10 to the 23rd power, all right? You take the decimal and move it to the area of most significance, and then you can call that your number. All right, and we're going to talk about significant figures and how we can do this and know exactly where to stop with our decimal here in just a second. Okay, now significant figures is something that we're going to be having to deal with for the entire year. You have to know where to stop and where to round to in terms of significant figures. So if I were to tell you to round your answers to 2 significant digits, you have to understand where you need to put your decimal, where you need to stop your number, okay, and not keep going and going and going and going, okay? But the more significant figures you have, the more accurate or precise your data is, all right? So we're going to talk about how do we find what these significant figures are, right? How many of them are there in specific numbers? And to do that, we're going to use these numbers behind me. There are certain rules for significant figures, and the first of them is this. All right, it states that we ignore the leading zeros. So what exactly is a leading zero? When we talk about zeros here, we're talking about 0 the number, okay? Nothing crazy, just the big goose egg, right? Okay, now what is a leading zero? So I'll give you a couple of examples of what exactly a leading zero is. Right here, okay? This first example up here on the board has 0.001010. Okay? How many zeros are there before we even get to a number other than 0? All right, there are 1, 2, 3, all right? Surely. Now, we have a number other than 0 right here. Those are always considered significant, all right? So the leading zeros, here, here, and here, aren't. So how many significant digits do we have? We start with 1, our first significant number. We have another 0, another 1, and another 0. Okay? Now, this 0 isn't considered to be a leading 0 because it's trapped. It's sandwiched. All right? Now, these are considered to be leading zeros, so this actually has 4 significant digits. The other 3 aren't considered to be significant. All right? And that's because they're leading. And according to our rules, we ignore the leading 0. All right? The second rule says to ignore trailing zeros. So that means zeros after the fact. All right? Unless they come after a decimal. Something you're going to find in chemistry is that it's the science of exceptions. Okay, there's usually rules, but sometimes there are exceptions to that, and this is the case. If they come after a decimal, the zeros are significant. So let's look at another example. All right, over here we have 0.3000. Okay, so after the decimal we have 0.3000. The leading 0 is insignificant. Okay. If there was a 0.03, Okay, the 0 before the 3 would be insignificant as well, all right, because it's a leading 0. Now you're like, wait a minute, Mr. Hawkins, you just said if it comes after a decimal, it's significant. Okay, hold that thought. We're talking about after the number, okay, the number other than 0. So we've got 3 here, 0.3000, all right? Now, these 3 zeros are significant. This one is not. So our significant numbers are 3, 0, 0, 0, okay? Because these come after a number after the decimal. All right? So we have 4 significant digits here as well. All right? On this next one, 100.0000. All right? Now you may think that's pointless. Why would you put so many zeros? That's ridiculous. Okay? But in this case, we're being more accurate, more precise with our data. Okay? Now, there are no leading zeros here, am I right? When I say that, I'm pretty sure I am. There's no zeros before the 1. We have our 1, and then we have our numbers that follow it. Okay? So we have 100.0000. All right? After the decimal, those are still significant. So how many significant figures would we have here? We'd have 1, 2, 3, 4, 5, 6, 7. 7 significant digits. All right? 7 significant digits. They are not, the zeros in this case are counted as significant. They are important because they come after the decimal, all right, and after the original number. So the next thing we're going to look at is everything else, the rule number 3, and it states that everything else is significant. Any number is significant. You got to understand that. All right, so right here, let's take a look at our next example, and we'll talk about scientific notation when we do this as well. So this second example right here has 1, 2, 3, 0, 3, 0, 0, 0. All right, how many significant digits do you think are there? It's kind of difficult to think about. All right, now, is there a decimal here? No, there's definitely not. Okay, so that means that the trailing zeros are not important, okay, because there's no decimal. If there was a decimal, they would be important. If there is no decimal, they are not significant. So we have 1, 2, 3, 0, 3. All right, this one's sandwiched. Sandwiched ones always are significant. So our significant number is here is 1, 2, 3, 4, 5 significant figures. Now you may be scratching your head, okay? Sandwich zeros, they count as significant digits. These are not, okay? That's important to consider there as well. Now if there was a decimal here, they would be considered significant, but that's not the case. All right? Let's look at a scientific notation example as well. Okay, we have 7.5701 times 10 to the 24th power. Okay, so that means that you move this decimal 24 times and add that many zeros. Okay, so the other numbers aren't important other than the zeros, right? The zeros are gone. They're not important. They're insignificant, the extras that you would add in. But the important ones are the ones that you see right here. This is why significant digits are important, okay? 6.02 times 10 to the 23rd, we have 3 significant digits in that. All the rest of them don't really matter as much. Okay, so right here, we've got 7.5701. Okay, how many significant digits do we have? 5, all right? 5 significant digits. 1, 2, 3, 4, 5. Okay, the extra zeros for this 24th power, however many times we'd have to slide that decimal, they're insignificant. Okay, so hopefully you kind of have an understanding of this. This is something we're going to be working on in class. It's a more difficult concept, but it's something that takes work. It's something that takes practice, and don't give up on it. Don't get frustrated, all right? If your head's spinning from all this talk about zeros, keep these rules in mind, all right? We're going to be working on these tomorrow in class. We'll see you next time on A Moment of Science.